Right, hello and welcome. This is quite a different video actually, because we've been doing tutorials in the past and they've been a bit, they haven't been exam based, they have been exam based, but I haven't gone through any exams is what I'm trying to say. And that's going to change today, because today we're going to do the AQA AS Physics Unit 2 January 2010 exam. Now I'm gonna go through each question as if I was doing an exam, and I will highlight bits that you might need to look out for. The one thing I won't do is being put up like sort of the exam on the side of it. I tried that and it didn't sort of work before, so well it would have worked, but it wasn't very clear, so I'm just going to go through it this way. Hopefully if you want to just have the exam paper next to it, or I don't know if you want to just listen to me go through a couple of questions, it's completely up to you what you do. So the first question, obviously I'm looking over here because I've got it over here. It says a digital camera was used to obtain sequences of tennis balls being struck by a tennis racket. I'm just going to draw out the main diagram in this picture. So yeah, so this is the end sort of tennis racket, if you like, and the ball is there, and there, and it's in the question. It's labelled, the first ball is ball D, ball E, ball F, ball G. Now they're not different balls. I've kind of said that, but they're not really what they are. It's different snapshots. So I'm just calling them the ball at point D, the ball at point E, the ball at point F, etc. Now it tells you in the question that there's a difference in distance, easy enough, of 0.68 metres. Now that's very well and good, but it says in the question each one of these is 5 milliseconds. So 5 ms. Now that's not meters per second, it's simply milliseconds. 5 milliseconds. 5 milliseconds. Sorry. And it's asking us to work out the horizontal velocity, so V is what we want to know. We've got distance, I'm going to label that as S, which is 0.68 metres. And we've got T. Now for T, we don't just simply take one of the 5 metres per second. It's asking us to find out the difference at the velocity between D and G. Now obviously we don't know the initial velocity, all we care about is the end velocity, so we can't use a Suvat equation for this. But for time, we simply add up all the times. So the time is 15 milliseconds, but obviously we need to put that into SI units. So when we convert it to SI units, we divide it by 1,000, and we can do that on a calculator. 15 milliseconds over 1,000, because there's 1,000 milliseconds in 1 second, because there's 0.015 seconds. I may have been off by a factor of 10 there, but we'll just see, and then I'll let you know if I have been. So there's 0.015 seconds. Now we know that speed equals distance over time. Speed, it's a bad way of putting it actually. V equals S over T. Now we've got T, we've got V, we've got S, sorry. So we can simply put these into our equation. We don't need to convert S, it's already in SI units. So let's crack on with some banter. So V equals 0.68 metres over 0.015 seconds. And if you put that in your calculator, it should come out to be 45 metres per second. Yeah, it actually comes out to 45.3 metres per second. 3 recurring, but that is just equal to 45 metres a second, really, because we don't care about the 0.33333 metres per second. Hopefully you've got that. Let me just see if it... Yeah, hopefully you can see that alright. I think it's going out too much. Let me just... Damn it. Sorry. Right, sorry about that. See if that's made a difference. Sorry. Yeah, there you are. It's a bit better, isn't it? Sorry. You never know. So that's first question out of the way. Yeah. No. And my leg's damaged. Never mind. So let's get rid of that. So we've done. That's the first question. Now, the next question, oh, damn it. Yeah, the next question asks us, well, calculate the acceleration. I'll leave this, I'll put this as 1AI, and this is 1AII. It says calculate the acceleration between this point and this point. Now this, we can use the standard equation, but you need to rearrange it to show you're working out. So we know V equals U plus AT is a SUVAT equation. We rearrange that to get our acceleration formula, which we should know, which is A equals V take U over T, and A is equal, well, that's the end velocity. You do need to note down your, so I'll just put this down here. V equals 45.3 recurring meters per second as we rounded it down, but for accuracy in this one we leave it to what we got it before. U, well, that's 0, as it's just leaving the part of D, 0 meters per second. So that should be U, yeah. Just make that a bit more obvious. We don't know A, so just put like a little question mark next to it. We know T is 0.015 seconds. It does seem easy, this stuff, but you need to do it anyway, because sometimes the difference between a grade. So 45.3 take 0 over 0.015. Yes. Now, as you can see, that is going to be a very large number. So put that in our calculator. 0.015. And that should get you an answer of 3022.2 meters per second. So you can round that down in different ways, but that's just the way I've done it. Let's see if that's right on the mark scheme, because I'm not 100% on that. Yep, that's correct. Sorry, just making sure. Right, now the next part of the question turns into a projectile question, as it says the ball at D, so this point here, was projected horizontally from a height of 2.3 metres above the ground. Don't worry about this, I'll draw it out for you in a minute. I'm just going to leave this and rub it out in a minute. Show that the ball would fall to the ground in 0.7 seconds. Okay, so let's rub this. We don't need this really anymore. We can always come back to it if we need to. Right, so my fancy new rubber. Right, so we don't really need to know this actually. For this question. Right, so this is question 1B part 1. So we've got our ball D, ball at point D, so its initial velocity is 0, so you know, that's something to put on. But if we're measuring the time it takes to fall, I don't think that has much of an effect, as the vertical displacement does not take into the horizontal velocity. So it tells us the ball is 2.3 metres above the ground. And it's going to do something like that. And this is just the floor, sorry, difference in height. Now we can say this is the x displacement, because it's going along, and the y displacement is going up, so that's the y. Now we know, or you should know, that the y displacement, so y is equal to 1/2 times gt squared. Now we know the y displacement, which is 2.3 metres, so put that in, equals 1/2 of g, which is 1/2 of 9.8 times t squared. Now we do know t, we're giving it in the question 0.7, but we've got to prove it, so you can't just wang it in there. So what we need to do is simplify this, so 2.3 metres equals 1/2 of 9.8, which is 4.9, times t squared, and we divide 2.3 metres, simply simplify it down, 4.9 equals t squared, t equals, I'm not doing any calculations yet, just so you can see where I'm getting it from, t equals the square root of 2.3 metres over 4.9, and that should get you an answer. Yeah, square root of t squared is just t, so if we put that in our calculator, 2.3 over 4.9 equals 0.685, which when you round it up, t is equal to 0.7 seconds. Okay, so that's that equation there. I mean, you don't need to check the mark scheme for that, because if it says it should be about 0.7 seconds and you get an answer when you round it up to is equal to 0.7 seconds, as I've done there, then you're obviously going to be right. You just need to, make sure your method mark is right. Otherwise you can't just skip it. You can't skip all these bits, because it's giving you the answer. You don't get marked for the answer, or you get marked for working. So yeah. See the next part of the question asks us. Oh, and I'm not going to rub that off, as it's still asking the horizontal bit, but I'll just do it in the corner down here. So the next part, 1b part 2, asks us, it says, calculate the horizontal difference, so x equal, and we don't know x, we want to find x, that the ball will travel after it leaves the racket before hitting the ground. Assume that only gravity acts on the ball as it falls. So they're basically telling us to ignore the effects of air resistance, which you wouldn't be expected to know at this level anyway. So, how can we work this out? Well, we've got t is equal to 0.685 seconds. Now the reason I've not put it as 0.7 is we want to keep it as accurate as we can, and we can do that without rounding it. So that's the answer. I've got my calculator for the time. Don't know if you can see that very well, but so that's how calculator I've got for my time. So we know x. Well, how do we know about x? Well, x is equal to ut. We don't know x. So I just sorry, give me a second. Sorry, one sec, that's not right. Are they done? What's the times time? Right, Right, sorry, just give me a second. Alright, okay. So it says, not at D, sorry, that's why I was getting myself confused. So, it's not at D, it's at the end of the racket before it hits the ground. So that means it's got the highest amount of velocity thing, sort of thing. So our velocity, sorry, get rid of this, is equal to 45.3 recurring. Remember that figure? Equals V. And distance equals speed times time, so S equals Vt, and we just put that into the equation. S equals 45.3 times 0.685, and that should get us a distance value equal to 31.3-ish. I've got my calculator. Meters, let's put that in meters. So that's that main block of that question done. See what the next part asks us. So we don't need to write anything for this. Well, we do actually. It's an exam. It's a stupid thing to say, banter. But I'm not going to write anything down purely because otherwise I'd just be writing words. I'm purely doing the calculations for you. So it says, explain why in practice the ball falls will not travel this far before hitting the ground. Now you can use sort of infer what they've sort of told you before. They said in the previous part, they said assume that only gravity acts on the ball as it falls. So that's enabled us to work it out without gravity. No wait. No, sorry. Yeah, it basically telling us that we're ignoring the effects of air resistance, as I said. So if it says explain why in practice ball will not travel this far before hitting the ground. Well, yes, gravity does not affect it, but air resistance does, and we've not included that in our calculation. We've assumed there's no air resistance, so there's nothing pulling the ball backwards. When it's travelling horizontally, the vertical velocity, or the acceleration due to gravity, which is 9.81, does not affect the ball. So we've not calculated that in our answer, and we calculate about 32 metres. So we need to state that in that part of the question. So one of the points he's looking for is the fact that the air resistance is, we've not included that, so that would mean the ball will not travel as far. See if there's anything else to add to that. Yeah, and you just need to mention that the fact that air resistance will slow the ball down. That was your second mark. So your 2 marks for 1B part 3 is explaining why the ball will not travel. So the air resistance will affect it, this will slow it down so it won't travel as far. They're the main things that you need to say for that question. See if there's anything else on that, so that's a new question. Yeah. Now this one is part 2, AI, or first part, is, well, question 2 actually is quite a difficult one. I think it's one of the most confusing things on this paper, even though it's quite a simple topic. It doesn't work for most students on the exam, including me. So we're going to have a go at this. We don't need to, hopefully you've got that before, so I'll just get rid of all this. Oh dear, long day. Right, so this part of the question says, I'm not going to write this first 2 part 1. It says define the moment of a force. Define moment. I'll just write it down there, but I'm not going to actually write the definition, I'll say it. So the moment of a force is a force times the perpendicular distance from the pivot. Basically, you'd state in the equation in words, that's all it's asking. But the next question, sorry, it's far. It says, state and explain which pair of springs, front or rear, will be compressed the most. Now, I've not drawn anything, so if you haven't got the paper next to you, or if you're just listening to me, then I'll draw it out, the main things that you need to work out. So you've got a truck here, a very accurate representation of a truck. Some guy just has a truck that has springs like that. It's not even connected to the body, but you know, this is physics, we can do what we like. So, it doesn't have to be a truck, I guess. There you go. That's not very good. Anyway, the centre of mass is here, and the truck has a weight of 14,000 newtons. And the wheel here is point B, and the point here is A. X is just above the wheel, which is where X. Yeah, so that's point X, and it tells us the distance between A and B, or X and B, is 2.5 meters. Again, if you can't see this, you might want to just go back and look at the actual online version. So, and then it tells us the distance between the weight, which is here, and the end of the truck is 2 meters. And the distance between B and the middle of the truck, centre of mass, is 1.4 meters. And they're the main things it tells us. And obviously these two are the springs. So it says state and explain which pair of springs will be compressed the most. Now, without doing any calculations, you're just balancing on it and the fact that it's an equilibrium question. Now, they won't give you one that'll say it's at 0.5 degrees out of equilibrium even. It'll always say it's in equilibrium for this one. So, as we know, moment equals force times perpendicular distance. So as they're all perpendicular, you can assume that they're in equilibrium. So the shortest distance, if it's in equilibrium, the anti-clockwise moment will be equal to the clockwise moment. So it says which pair of springs will be compressed the most. Now, if the so the moment of the force of that will equal the moment of the force of that, if they're going clockwise and anti-clockwise. So there's basically what we're saying, for them to have the same moment, the one will have the bigger force. If the moment's going to be the same, the one with the bigger force will have the smaller distance to equal the same moment. And it's asking us which pair of springs, front or rear, will be compressed the most. So that means we'll have the most force on them, as we'll go into springs in one of the tutorials if you've missed that. So whichever spring is the closest to the centre, that will have the biggest effect. Sorry, the biggest force on it. So we know the distance at B is 1.4 meters. However, what we need to do to find the distance between A and the spring, what we do is we know that's 2 meters there, that's 2.5. So we take 2.5 from 2. So X, between X and the centre, it's 0.5 meters. Hopefully it's quite self-explanatory. So if X is spring at A, is 0.5 meters away, and spring at B is 1.4 meters away, then we know A has a smaller distance, so it must have the bigger force to equal the same moment. So therefore, A will have the bigger force to be compressed the most. But it says front or rear, so that springs are at the rear, so we know at the rear they're going to have the biggest force. So I just put up here just a 2A part 2 rear. Hopefully that's made sense. Right. Okay, so let's see what time we're on. Right, well, we'll go another, we'll finish question 2 for this tutorial, and then we'll go start another one. Okay, so, yeah, so that's part 2. Okay, so what does the next part of the question say? It says, by taking moments about B, calculate the force exerted by the truck on each rear spring. Now, this is a 2D drawing, but there's 2 springs on each side, obviously, because you don't want to find just doing that, you know, you mess up the moments, equilibrium, etc. There's a lot of words in that sentence. So, It says calculate the force exerted by the truck on each spring, and we're at B. So we need to work out the sum of the clockwise moments equals some of the anti-clockwise moments. So B times 2.5, because that's the distance between B and A. B times 2.5 meters equals. Oh, sorry, no, that's wrong. I'll explain why in a minute why I've done that wrong. So B times 1.4, because the weight is there. B times 1.4. Oh God, I can't even write anymore. 1.4 equals F times. Oh, sorry, I'm just completely messing this up. Just make sure I'm not messing it up too badly. Give us a second. Oh yeah. Okay. So if B is going this way, it's going upwards, and A is going upwards. Sorry, there's a lot of words on there. So B is going anti-clockwise, and B is going anti-clockwise, and A is going clockwise. So B times 1,000, because there's no point here. There's no point that we're measuring. So it's quite confusing. So B times the distance, perpendicular distance, which is 1.4 times 1,400 newtons. And we know that. So 1.4 times 14,000 newtons, is equal to F times 2.5 meters. Just check that's right. I'm checking because I don't want to take you down a wrong path and then end up explaining a different question. Yeah. So, why have we done that? Well, 1.4 times 1400 is the anti-clockwise moment. But A, now we need to work out the force at A. So each rear spring and A being the rear spring. So if B is turning it anti-clockwise, A must be turning it clockwise. Now I know the distance between A and B. Now it's not 0.5 meters because we're taking the moments about B, not the middle, not the centre of mass of the truck. So that's why we're doing the 2.5 meters. And F is just the force at A. So if we cancel that out, so F is equal to 1.4 times 14. I'm not doing any calculation. 1400 newtons over 2.5 meters. And F is equal to, if you've done it right, if I've done it right, it should be 7840. Just check. If I have get this right, not done my assume at all. 1400, 2.5. Oh my god, I'm correct. Crazy is that? 40 newtons. So that's your support force. Now, we know that there are two springs at the back of this truck. So we'd simply divide this by 2. So F, if you divide that by 2, yeah, F is equal to 920 newtons, or 3,920 newtons, acting on each spring. Because they're equal, assuming they're equal amount of force, they're made of the same spring. But that all, again, is something about springs you need to learn. If you don't know that already, you can have, explode your mind with all the physics we're going to do. So hopefully that's you've understood that. I've tried to explain it in the simplest way I could and gone through it for quite a long time. So we'll see you in the next video.